नमस्कार। आज मैले क्लास 8 को साइन्स एन्ड टेक्नोलोजी युनिट 8.1 म्याग्नेट लिएर आएको छु। Fill in the blanks. All the magnetic substances are made up of magnetic molecules. The process of forming a temporary magnet keeping a magnetic substance close to a magnet is magnetic induction. In magnets, magnetic molecules are arranged in the form of open chain. Keepers conserve the magnetic force of a magnet. Hammering a magnet causes demagnetization. Write short notes on magnetic induction. Magnetic induction is the process by which a material like iron becomes magnetized when placed near a magnet. The nearby magnet's field causes the material's atom to align, creating a temporary magnetic field. For example, a paper clip near a bar magnet becomes magnetized and can attract other paper clips. This process is used in applications such as transformers and electric generators. Molecular theory of magnetism. The molecular theory of magnetism states that each molecule in a material acts as a tiny magnetic unit known as magnetic molecule. In non-magnetized materials, these magnetic molecules are randomly oriented, cancelling each other out. In a magnet, they are arranged in an open chain due to which they have got magnetic force. Demagnetization. Demagnetization is the process of reducing or eliminating the magnetic properties of a material. It can occur naturally over time or be induced through various methods such as heating, hammering, or exposure to strong magnetic fields in the opposite direction. Demagnetization reverses the alignment of magnetic domains within the material, causing them to become randomly oriented and cancel each other out, resulting in a loss of magnetism. Give reasons. A magnet cannot be made from a copper plate. A magnet cannot be made from a copper plate because it is non-magnetic substance and does not retain magnetism when removed from an external magnetic field. The magnetic poles of a magnet cannot be separated. The magnetic poles of a magnet cannot be separated because they always exist in pairs, a north pole and a south pole. If you try to break a magnet into smaller pieces, each piece will still have both poles. This property is fundamental to magnetism. A magnet demagnetizes if heated. A magnet demagnetizes if heated because the open chain molecules of magnet changes into closed chain molecules due to which it loses the magnetic force. A magnetic body works as a magnet when it is kept close to a magnet. When a magnetic body is placed close to a magnet, the magnet's field induces magnetism in the body. This aligns the magnetic molecules within the body, causing it to act like a magnet temporarily. Once the external magnet is removed, the induced magnetism will disappear and the body returns to its original state. Keepers are used while storing magnets. Keepers are used while storing magnets to create a closed magnetic circuit which maintains the magnet's strength and prevents demagnetization. Repulsion is the shear test of magnet. Repulsion is the shear test of magnet because it only occurs between two magnets with like poles uniquely conforming their magnetic nature. Demonstrate by conducting experiments. Magnetic poles of magnet cannot be separated. Materials needed: bar magnet, paper or cardboard, iron fillings or magnetic compass. Procedure: place the magnet, take a bar magnet, note the location of its north and south poles. Testing with iron fillings: place a piece of paper or cardboard on a flat surface, sprinkle some iron fillings evenly on the paper. Observe the magnetic field. Gently tap the magnet to ensure any loose fillings align with the magnetic field. Note the pattern formed by the iron fillings. Typically, they will form lines between north and south poles of the magnet, illustrating the magnetic field lines. Attempting to separate poles. Try to physically separate the north and south poles of a magnet by cutting it, breaking it, or using another method. Notice that regardless of what you do, you cannot isolate a single pole. If you break the magnet, you will simply have two smaller magnets, each with its own north and south poles. Using magnetic compasses, place a magnetic compass near each end of the bar magnet. Observe how each compass needle aligns with the magnetic field. One end of the compass needle will point towards the north pole of the magnet and the other end towards the south pole. Magnetic induction occurs. Materials needed: coil of wire, bar magnet, galvanometer, connecting wires. Procedure: preparing the setup. Taking the coil of wire and connect its end to the terminals of the galvanometer using the connecting wires. Ensure the galvanometer is set to a sensitive range or mode suitable for detecting small currents. Position the magnet. Hold the bar magnet steadily with one pole facing towards the coil of the wire. Observe initial reading. Note the position of the galvanometer needle. Typically, there might be no or minimal deflection initially. Move the magnet. Quickly move the magnet towards or away from the coil of wire. Observe the galvanometer for any deflection or movement of the needle. Note the results. You should observe a momentary deflection of the galvanometer needle when the magnet is moved relative to the coil. If you move the magnet towards the coil, you may see a deflection in one direction. Moving it away causes deflection in the opposite direction. Repeat and analyze. Repeat the movement of the magnet towards and away from the coil several times. Note the consistency and direction of the galvanometer needle deflection each time the magnet's position changes. Answer the following question. State the molecular theory of magnetism. The molecular theory of magnetism states a magnet can be made of magnetic bodies only. A magnetic body is made of tiny magnets called magnetic molecules or molecular magnets. When a magnetic body is not magnetized, molecules form a closed chain. When a magnetic body is magnetized, molecules form an open chain. What is the magnetic molecule? How are they arranged in a magnet? The tiny molecule in a magnet which has got both north and south pole is called magnetic molecules. Magnetic molecules are arranged in open chain in a magnet. You can see closed chain and open chain. So when they are in open chain, they act as magnet. Why does a magnet get demagnetized when hammered? A magnet gets demagnetized when hammered because the magnetic molecules in a magnet change to closed chain from the open chain, converting the magnet into magnetic substances. Define demagnetization. How can we conserve magnetic force of a magnet? The process of losing or removing the magnetic property of a body is called demagnetization. We can conserve magnetic force of a magnet by handling a magnet safely, avoiding hammering and beating of a magnet, avoiding heating of a magnet, storing the magnet properly by using keepers. What is magnetic induction? Sketch a diagram showing magnetic induction. When a magnetic substance gains magnetic force when placed in a magnetic field of a magnet is called magnetic induction. A bar magnet has more magnetic force at poles and less in the middle. Why? The variation in magnetic force between the poles and the middle of the magnet is due to the concentration and distribution of magnetic field lines. The poles have a higher density of field lines, resulting in stronger magnetic forces, whereas the middle of the magnet has a lower density of field lines, resulting in weaker magnetic forces. Thank you so much for watching my channel. Please do like, comment and subscribe my channel. Thank you so much.